All right, let's face off. ChatGPT versus a human to see who can finish LeetCode problems faster. Hi, I'm a senior engineer at a FAANG company, and today I'm going to race ChatGPT on 3 LeetCode problems. First, some ground rules. The timer starts when you load the web page. 2, the timer stops when you get an accepted solution, no matter how inefficient or how poorly ranked. All that to say is, this includes the time it takes to copy and paste from ChatGPT. Here, I've selected only easy problems on LeetCode and ordered from the most recent. Makes it less likely that ChatGPT has trained on and memorized these problems already. Let's get started with the first one. All right, looks good. That's number 1. Let's move on to the next problem. All right, looks good. Let's move on to the next problem. All right, looks good. We're done here as well. All right, now we're back to the home page. You can see here I've got the 3 different problems that we've just completed. I've also loaded up each of those problems and I've cleared out the original solution that I wrote. So let's plug these into ChatGPT and see how it fares. Oh, there we go. That was pretty fast. All right, let's move on to the very next problem. Okay, this is not looking good. Let's move on to the last problem. All right, that was the 33 problems. Now let's tally up the numbers and see how we compare. This was the first problem that we went through. I'm going to talk about the problem very briefly, then go over the solutions that both I submitted and ChatGPT submitted, as well as their differences. Let's start off with what this problem is actually asking for. Here we have a grid of n squared different values, and exactly 1 value is repeated, exactly 1 value is missing. So here, the very first reaction I had was just to throw everything into a set to find that missing value and then to actually find that duplicate. So here we'll see on the right hand side here, you can see that at the very beginning I'm throwing everything into a set. I'm just iterating over all the values, all n squared values, and if it's in the set already, then I have found my duplicate. Then, knowing that all the values are supposed to range from 1 to n squared, I check for every single one sequentially, and that's how I get the duplicate and missing values. Now let's compare that to the solution that ChatGPT actually created. So here we've got the last submitted solution. Right here, ChatGPT does basically the same thing, but instead of using a set, they do something clever, which I do have to admit. Here they have an array where it goes from 1 up to n squared. Since you know that there's a set of consecutive values, this is much better than having some generic, hash family that whatever the set is using by default. So this is pretty clever. Otherwise, the logic looks pretty much the same. Here you can see that if the count already exists, then you found your duplicate, just like I had previously. And down here, they're iterating over all the possible values to find their missing value. And there you go, you have the answer right here. So let's look at the statistics for these 2 submissions. If we go to submissions right over here, you see that the bottom one, the first one, is the one that I had done. 131 milliseconds versus theirs 145. I would say this looks pretty much like noise. The memory right here, a 0.1 megabyte difference, is probably also due to noise. So both of our solutions look pretty comparable. Now, for the ultimate statistic, the one that we care about the most, how long did it take each of us to actually come up with the answer and reach that final accepted solution? Let's take a look here. And unfortunately, it looks like I was absolutely destroyed by ChatGPT here. That's a whole whopping difference of 30 seconds. So unfortunately, first one goes to ChatGPT. Let's go on to the next problem. This is problem number 2. In this problem, we have a set of numbers, and in effect, you're looking for any number that has a value greater than 0. Now, here's a catch though. For every value that's greater than 0, you will actually decrement all the subsequent values by 1. Now, the catch is you don't actually have to do this seemingly n squared operation. Instead, all you need to do is keep track of the number that you've counted up so far, and for every value afterwards, just make sure decrement by that value before checking if it's greater than 0. So in my solution, which we'll see in a second here, so in my solution right here on the right hand side, you can see that I'm actually just using the count right here in the check for greater than or equal to 0. I don't actually have to decrement all the values using an n squared operation. This now becomes linear time. Now let's look at the solution that ChatGPT actually generated. Here you can see that ChatGPT unfortunately takes the n-squared approach. Here you have a loop over all the subsequent values, and it actually decrements those values by 1. And now this is a trick question. It could have done this in linear time. So if you look at the submissions tab right here, you can see that the 58 millisecond solution that I submitted is twice as fast as the 107 milliseconds that ChatGPT submitted. So here it looks like I actually did provide a better solution in terms of runtime complexity. Now let's look at the time it took for both of us to actually submit these solutions. And thank goodness, it looks like I actually did outperform ChatGPT here, so that's +1 for the humans. Let's move on to the third problem. So here is our third problem. Here we have two different lists of numbers, and we want to return the number of values in the first list that exists in the second. And then we also need to return the number of values in the second list that belong to the first. In the end, your function should return 2 counts of values. As you may have already guessed, as soon as you saw common elements, this probably involves some sort of intersection between sets. So that's the very first thing I did. First, I found those common values by taking intersection between 2 sets. Then, to actually count the number of values that were included in that set per list, you can see right here, I've got a sum iterating over all the values. Let's see now what ChatGPT wrote. So here you can see ChatGPT's solution. It actually starts off fairly similar to mine, where they construct sets from the input lists. Now, to actually count the number of elements that belong to the other list, they right here check for membership in the other set on every single element. So the difference is that I pre-computed the intersection. Here they're checking membership for every single item. And the runtime complexity is about the same, so this doesn't really matter. Now let's look at the statistics for both of our submissions. Runtime here looks like 138 milliseconds versus 150. That's pretty small. That's probably due to noise. Looking at the memory here, 16.2 versus 16.3 megabytes. Again, probably the same, just because we've looked at these 2 pieces of code and the runtime and memory complexity should be identical. Now, let's look at the statistic that we actually care about, amount of time that it took to actually get to that accepted solution. And so this looks very, very close. Thank goodness, looks like I did outperform ChatGPT here. So that's +1 again for humans. And this brings us to our final count. That's 1 for ChatGPT, 2 for humans. Thank goodness, looks like us human engineers are still in the game and still have jobs. If you want to see more AI versus humans, let us know in the comments, and thanks for watching.